All done.
Thank you. So welcome everybody. This is the Dementia Knowledge Network, which is our fortnightly catch up. Today we have Carol Newman coming to speak to us about brain plasticity, as you can see on the screen there. So thank you very much, Carol, for coming along. I would like to acknowledge the Wurundjeri people, who are the traditional custodians on the land in which we meet. I would like to pay my respects to the elders, both past and present, and also emerging. So I might hand over to Carol now, if you're happy to give us a little brief intro, and then feel free to jump into your presentation. Thank you very much.
Well, hello everyone, and thank you for the invite, Elizabeth. And I feel very pleased to be here and pleased to be among people who are trying to do things to help people in my situation. I can't see myself on the screen, so can you see me? You can, okay. So let me just hold up. So I'm a neuropsychologist and I went to university as a mature age student. And as I've said to people that, you know, I started as an undergraduate doing psychology and then went right through until I did a PhD. And I was like a dog with a bone. Once I got into this thing that I loved, I just kept going. So, and I just loved everything that I was learning about the brain. And so I did a master's in neuropsychology, and then I did a PhD in talking about brain development in premature babies and long-term effects. So this presentation is a little bit about what is the process by which plasticity works, and plasticity works both for better or for worse. And I use that term purposefully because it's part of what you say when you get married, for better and for worse. And as a carer, I have found both better and worse in our relationship. I have just come today from the nursing home where my husband is, and I was feeding him, and he was just in the best mood. And there was a musician there, and I got involved and took all my musical instruments that I used to use with my premature babies and premature children. And it was like a little party, and he was in a fabulous mood. But other times I can go there and he's crying. So it's certainly sometimes better and sometimes worse. And just to show you what a nerdy neuropsychologist does, and that is they have a soft toy. Can you see it? This is my neuron. Okay, I can't hear any laughing. So anyway, I'll just keep going.
Carol, I have one of those as well.
Have you?
Not very cuddly, but nice nevertheless.
That's right. So I was actually at Monash one day and went into the book shop, and there it was. I have to buy that. Okay, so there it is.
I think when in my chemistry class, I have similar thing toy like that. So I think this remind me of something.
Okay. So what you can see on that slide, the first slide, you might think, you know, someone's just got some coloured pencils and drawn a whole lot of lines. No, this is actually a photo, you know, that they do under microscopes of a whole lot of these parts of the neuron in like a river going together. So in the parlance, it's called a tract. So you all know that the brain has, you know, hundreds of billions of neurons, and every single neuron can have about 10,000 connections to other neurons. So just imagine this little fella with those. So this would be the axon. So this is where the information comes in from other neurons. And this is the dendrite, which is where the information goes out to another neuron. So just imagine, and you can see some cell bodies there. I don't know how many cells, how many projections you could see there, but there would be tens of thousands. So just imagine, I'm not sure if I can do this, if up the top there that's all coming, say, from the eye, and from the eye, the neurons are sending messages to the part of the brain, which is right at the back of the brain, right down here, called the occipital lobe. So, and it might be that eye is, and I'll use this example all the way through, say the child or the person is seeing a black barking dog, there's a message that comes from the eye. So the eye is seeing, not making sense of what it's seeing. So it has to go all the way back to the occipital lobe for the perception of the visual image. Now, you all know this, but the brain's really complicated. Let me just make sure I've said that. So just going back to that first slide, we're not born with those tracts. There are some tracts already in the brain when we're born. And those tracts would be to do with, breathing and maintaining body temperature. But in fact, as the child gets lots of experience of the world, and so they see dogs, they hear dogs, they get feelings about dogs, they own a dog, they touch dogs. So all of these tracts connect all different parts of the brain together. Okay, so this is, and you've all seen pictures like this. Now, the lumpy outer surface of the brain, you probably, sorry if I'm telling you to suck eggs, but that's called the cortex. And the reason it becomes so lumpy like that is because as the brain gets bigger, and just by the way, a newborn baby's brain is about 400 grams. By the time the child is 1 year old, it's not about 900 grams. And that's why doctors are forever measuring the head circumference, because as the brain grows, so does the skull. And I haven't been game to measure my husband's skull, but I can see that it's getting smaller. Just by the way, so is mine, because his caps now fit me. So, the lumpy outer surface of the brain is where the cell bodies are. So here's my little neuron. And this bit here is the cell body. And so if this eye, if the eye sees a black barking dog, then from here, the message has to be sent all the way to the back of the brain here, which is the occipital lobe. And so the occipital lobe will see, something black, it will see a shape. It might see something moving, it might see a texture. And then from the ear, the sound from the ear will go to the auditory cortex, which is just here. And so there will become connections between the visual cortex and the auditory cortex, so that barking and the sight of a dog goes together. But then there will, and just by the way, as it goes through in the middle here, there are subcortical areas that, and particularly with subcortical areas, particularly the limbic system and what's called the hippocampus, which is where memories are formed for the first time. So it gets to the occipital lobe, it connects in with the auditory cortex. It might then have to send messages to up here, which is the motor cortex. For example, will I run? Will I cry? Will I stand still? Will I pat the dog? So what will my what physical response will I have? But all of that is done in the frontal lobes. So the frontal lobes are the highest part of our brain, and that's where we make our decisions. So you can see from the eye and the ear, the simple thing of seeing a black dog is important. So on every one of these little sort of sausage things, there are just millions of cells, and those cells have projections that go, and I'll show you pictures of this later, but each cell has a specific job to do. So, for example, in the occipital lobe where our eyesight is, I'm a bit hazy about this, but years and years ago, there were these two men, Hubel and Weasel, who won the Nobel Prize, and they raised kittens in on their own, each one on their own, in a circular sort of enclosure, and all the kittens could see were vertical lines, and so they couldn't see, they couldn't see other lines of any other orientation. And what these two men realised was that with sight, and certainly with a lot of the other senses, we now know the other senses, that there's a critical period. So if you don't see horizontal lines, for example, within, say, the first 3 months of your life, then you will not be able to see horizontal lines for the rest of your life. So when they took these kittens out of their enclosure, if they saw a fence that had a horizontal post, then the kittens couldn't see it and they would bump into it. And I've got an experience of that in my own family. As I said, I went to university as a mature age student, and I found out in one of my very first lectures that if our eyes are not straight, then we do not develop three-dimensional vision. So, you know, our right eye projects to our left hemisphere, our left eye projects to the right hemisphere. Somehow or other, when it all gets together, it works out an algorithm and it works out three-dimensional vision. But if the eyes are not straight, then we don't develop three-dimensional vision. And my daughter was in prep when I went to university, and she had an eye that just kind of went in and out just slightly, ever so slightly. So I've taken her to the doctor. The GP couldn't tell which eye was not straight. Then I take her to the eye specialist. Then I take her to the School of Orthotics. And sure enough, not only did she have no three-dimensional vision because she passed that 3-year critical period, but in fact her brain was starting to shut down to her right eye because it was not getting a, you know, consistent message from that right eye. So just, you know, that's just a, I guess, a little aside. All right, so the little child sees the black dog, and I'm just trying to, there it is, sees the black dog. The decision making is made here in the frontal lobes, and that will be based on a whole lot of things. Have I seen a black dog before? Have I got a memory of another black dog barking like that? Is it my black dog? Is it someone else's black dog? Is it on a leash? And so there's lots of decision making that has to happen. Oh, and one of the most important things is deep in here is the limbic system, and the limbic system is the emotional part of the brain. So when the child sees the black dog and there's a memory of seeing a black dog before, that memory could be good or bad, and so that will affect how the child will react to this dog. We are getting to the plasticity bit, don't worry. So here we can see on the left-hand side here, you can see a brain that's been cut through the middle. So we have two hemispheres, so that the bubbly bits kind of fold over and go down into the middle of the brain. And as you can see, that's grey matter. This little bit here, this is called the corpus callosum, and this is the strand of nerves that go from each hemisphere, from one hemisphere to the other, so that both hemispheres can work together. Child sees the black dog. They don't want to just respond with one leg. They have to respond with two legs, and so that they have to coordinate together. And then you can also see, sorry, there we go. See some of the parts of the subcortical areas, and then of course the brainstem and the spinal cord, because so many of those projections from so many, you know, those rivers of dendrites have to go down to the legs and to the arms. And this is just another representation. Each of those little sausage-like things is given a name, pretty much from one brain to another. The brain ends up being organised in a similar fashion. But for example, the part of my occipital lobe that sees a vertical line, for example, might be in a slightly different place to where your brain sees a vertical line. So it just depends on the child's environment. So I've already told you that bit. Now, you've all seen this before. This is a neuron, just like my little fluffy one. and this is where the plasticity comes in. So we have all these hundreds of billions of neurons. In fact, we're born with many, many more neurons than we end up with. So the ones that we don't use die off, and that is part of the whole process of plasticity. If we don't use it, we will lose it. And when I was working with mothers of prems, I used to say to them, it's a little bit, think about a room where there's a light in the ceiling. And the light, think of that light as a skill, say the skill to see a vertical line. But you know, this is a light. But in fact, there are light switches everywhere. There's light switches all up and down the walls, across the floor, across the ceiling, you know, maybe outside the room. So there are light switches everywhere. So what happens is the light switch that gets turned on over and over and over again is the connection up to that light that will survive and become stronger. All of those other connections with those where the light switch and the wires connect with the actual light, they will all die off. And so we have many less neurons and less axons and dendrites, many less neurons at 12 months than we had when we were born. So this cell body is the grey matter, and this is another example of a neuron. So this dark blue is the grey matter. The orange is the cell. This is an old person's thing anyway. And so this is, as you can see, the dendrite. And these, they're blue here, but really this is what we're referring to as the white matter. So on this dendrite, and by the way, we always see them cut off like that, but the dendrites can go for yards and yards, not just around the brain, but of course they have to go from the brain right down our spinal cord down to our toes. And so those dendrites are covered with this greasy stuff called myelin, and that's to make the message go through that dendrite really, really quickly. And when people have MS, the reason that they have problems is that myelin gets stripped away, and so the messages go slowly. Because the messages go slowly, the person loses abilities, and if the abilities are lost, then of course the cell will die. So we're back to this slide of kind of this river of dendrites, cell bodies, and axons. So just think about every experience that a baby and a little child and an older child has. And I'm just going to show you, oh, sorry, this is so as you can see, this is a picture of a real brain up here. So this is the grey matter. It's been cut through, and you can see all of those rivers of dendrites covered in the myelin going, and they will go from the front to the back, from the bottom to the top, from, you know, one bit here to the next bit there. It will go all the way down the spinal cord. Over here, this is another picture of the brain cut through. And by the way, it's cut through like this so that you can see the front of the brain and the back of the brain. And you can see the curly bit around the edge, which is the grey matter. And you see that grey matter is really, really curly. Now, as the number of cells in a child proliferate, and as the number of axons and dendrites come into their thousands, that the edge of the brain has to get curly to get more space. But what you can also see in this slide here is some of the subcortical grey matters. And so, for example, the child sees a black barking dog. It goes through to parts of the brain in here, particularly the hippocampus, which is it's just tiny, but it's where memories are formed. And so that becomes really, really important. And then it will go on to another part of the brain. So we've got the two of the things we've talked about are cells themselves and the quality of the dendrites, the projections from the cells. Now, we also have neurotransmitters, and you probably know a whole lot about these as well. So the ones that you can see here are just two of them, but there are many neurotransmitters. So, these are feel-good neurotransmitters, and I'll show you the role of the neurotransmitters in a minute. But if something goes wrong, for example, people who have Parkinson's disease have a problem with dopamine. And so one of the things that happen for people with Parkinson's is they're given dopamine to help them with the issue that's going on for them. So apart from the cell itself and the projection, we have the neurotransmitters. Now, in the cell itself, going along these projections, the message is projected electrically. So it's an electrical signal that goes down the body of the cell. But when that cell meets another cell, there's a synapse. So here we have, let me find my little, here we have a dendrite. I think it's going that way. So here we have a dendrite, and it's wanting to pass the message, I see black, or I hear barking, or an emotional message might be, I'm frightened. And so the message has to go from one neuron to the next. And the way it gets across this synapse is through the neurotransmitters. And of course, one of the neurotransmitters, or many of them, but are stress hormones, they're stress hormones. So, if a child is highly stressed, then the way this message gets across that synapse will be affected. So we've talked about now the cell itself, the axons and dendrites, and the way that they grow and their health. And we've also talked about the neurotransmitters. Now, there are lots of other things that will affect a child's brain growth, but, including their genetic inheritance. And there might be things in utero that happens, but by far and wide, the environment of the child will determine all sorts of ways in which a child's brain will grow. Now, this is a black dog, but these are three of my grandsons, and they've all got their hands in a bucket of mud. And if you can just think about the messages that are going backwards and forwards there. So the oldest one put his hand straight in, no worries at all. He could do that because I had made that bucket of mud, and he trusted me that there was nothing creepy, crawly or horrible in there. And so he could do it very happily. The little one, whose little chubby hand you can see at the bottom, he was much slower in being able to do that. So the message is coming from their fingers and from their eyes. There's also probably smell involved and maybe a bit of sound. But so messages are going all over their brain, backwards and forwards, messages going everywhere. So, including to the limbic system, which is, do I like this? Is someone going to splash me? Blah, blah, blah. So you know what brothers are like. So just think about this happening how many times a day with a little child. It's just incredible. And if you think about particularly the senses that have critical periods, if you think about if a child doesn't feel, for example, sandpaper or velvet or certain sounds, by the time that critical period's finished, and then they will never hear it. Now, for example, all of us are born with the ability to hear all the differences in different languages. But if we don't hear that language in our environment, you've probably all, tried to learn one of the languages when you're at school, like French or Chinese or German, and to get the way you hear the sound and can repeat it back right, often you can't do it. And that's because the ability to do it is gone. Because if you didn't hear it when you were little and you didn't practice it when you were little, then you will never be able to do it. And just to give you an example of this, I was on a holiday with my family when they were all younger, and we were in Central Australia, and we went out to an Aboriginal settlement, and the people there were going to find some witchetty grubs for us, and then they were going to dig them up and cook them on a fire, and we were going to eat some witchetty grubs. And so this lady, and here's the tree, and the witchetty grubs are in the roots of the tree. So she got a branch and she's banging the branch on the ground. No witchetty grubs in, just there. Around the tree a bit more, banging it again. No witchetty grubs there. Around a bit more, yes. Now, her ability to hear the sound that came back up from the roots of that tree to tell her that those roots didn't have witchetty grubs and these ones did, I think is, amazing. And if we tried to do that, if we tried to learn that at our age, we wouldn't be able to. So the environment that the child grows up in will make all those rivers of connections happen. So use it or lose it. And, when I got this slide ready, I'm actually just starting to learn to cry, actually, because I've known my husband's had Alzheimer's disease for a long time now, way before he was diagnosed. But if this is a normal brain, nice and curly, lots of grey matter, lots of white matter. But whatever the process is that stops those messages getting through means that the cells and the white matter is going to die. You can see how degraded this grey matter is and how much less white matter there is in it. So it's literally a case of, if you can't use it for whatever reason, whether it's because you were abused as a child or because you're in an environment where you were neglected or there was stress or you weren't allowed out of your cot for 6 years or whatever it is. So this is somebody whose brain used to be like that, but now it's like this because then a whole lot of cells and a whole lot of connections are being lost. So what is needed? Well, maybe some of you are much more up with the evidence of what we can do for people with Alzheimer's, but I am firmly of the belief that part of me bounces around with my husband on a joking level that is kind of what we used to have, but I pretty much have to think of him as needing love, if you like, but safety. And the big thing that I used to do with premature babies and their mothers was teach the mothers about attachment theory, which is about how babies have to feel physically, emotionally safe all the time and to come to expect it in their environment. And anyway, I can't prove this. I have no evidence for this, but it seems to me that that's what my husband needs. So pretty much I go in every day. I feed him every day. I'm trying to make some days where I don't go in, just so that I'm not totally worn out. And so I think that just like a little baby, the love that comes from me to him is not going to make his brain any better, but it's going to make his safety and his sense of, I don't know, belonging in the world or not being lonely or whatever it is better. And that. I'm finished.
Thank you, Carol. That was great. Oh, I didn't make my screen. Oh, I'm sharing. Wow, yeah, that was great. Thank you very much. Are you happy for us to open up the group of questions? Does anyone have some questions for Carol or anything they want to explore further? Penelope?
Yeah, I was just curious, and I think I might have worked it out, but you know how it always amazes me, the occipital lobe's at the back, and that sort of deciphers what the eyes see and tells us. And I guess it's at the back because then it's got to send all the messages, like you said about the black dog, you know, it's got to recognize the black dog, remember what it is, and then process, how do I feel about that? And then put it in context and work out what am I going to do about that, which is all decided in the frontal area. So I guess going to the back and then all those processes happening have to travel through the brain. Yeah. I think, would that be why, do you think?
Oh, I don't know. You know, I think, you know, we've had millions and millions of years of how we've developed our brain. And I think a lot of it is probably quite good, you know, the way it all is efficient. But it might be a little bit like that tail we've got at the bottom of our spine that doesn't really do anything, or, you know, something else that is, I don't know, developed for a reason. And now, you know, there's this convoluted distance it has to go to do its job. I don't know the reason for it.
Sure.
But I've thought the same thing, you know, how come it goes from our eyes all the way back and then it has to come all the way through all these other, back to the frontal lobes to work out what's happening. At least the ears have their bit right behind there. Yeah.
Exactly.
Auditory cortex.
Yeah.
And just by the way, there's you know, as I understand it, that the cells in the ear, you know, like for example, tones, you know, da 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 da. So there are cells that listen and hear those gradations of tones. There would be lots else that they hear as well, but just like I was talking about, say, gradations of a line or gradations of a colour in the occipital lobe, apparently it happens in the auditory brain as well. So it's very logical. It's complicated, but it's, you know, it seems to me it's amazing. There was one lady I knew who had premature twins, and she was a musician, and both her twins were deaf, and she used to sit them up right beside speakers in her lounge room and play music through these speakers in the hope that she would, you know, the plasticity of her children's brains would start to pick up the differences in sound. I mean, I don't know if it worked, but that's what she was doing.
Carol, we all work in different capacities with people living with dementia, and I know you've worked with the premature babies. Is there any practical, like what practical tips could you give us that we could maybe incorporate into our working with people, our activities we do with people, communication with people with dementia?
Look, you know, I'm not an expert in this area, but I do with people communication with people with dementia. Check it out.
Sorry, that's Siri answering me.
So, I mean, I go into this room every day, and first of all, I am devastated at how few people have visitors. Like, I go every day, and there's just been a lady who I actually went to the staff about because she was becoming dangerous she had early onset dementia, and she was becoming dangerous to other people in the room. And I was not really saying that they should move her on. I was really saying they should get an extra carer in there to look after her. Anyway, she's not there anymore, so I'm feeling a bit bad about it. Anyway, so I tend to be a bit like the Pied Piper when I'm in there, because I try and make up for all those people who don't have visitors. So just let me tell you one thing. So this is somebody who's got advanced dementia, and she's got really sparkly eyes. That, you know, she has that sundowner thing, you know, at tea time, where she gets really upset during tea time. And this is just something I've tried because it works with babies. So if you've got a little baby that is really upset, you know, so you see the baby and the baby does, and then the voice comes, oh. And if you mirror that back to the baby and you go, oh, and you make your voice do the same, you know, almost the same thing as the baby does, you cannot believe, if you do try that, if you've got babies in your life, do it. Now, it won't make a hungry baby not hungry, but somehow or other, the baby you get the sense the baby thinks, oh, you get how I feel. You know, it's like talking to your best friend, you know, that, oh, it's off my shoulders now. So she's in there and she's yelling at this lady the other night. And she goes, bugger, 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 bugger. And then she'll sing or she'll do something. So I could see, you know, and she then upsets other people at her table. So my husband was okay. So I've gone over there to her. I'm a bit scared about overstepping my mark there. So I'm going to, and she knows me, and her eyes light up when she sees me. So she's going, and I said, bugger, bugger, bugger. And then she said, daddy, daddy, daddy. And I say, daddy, 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 baby, baby. So I'm really saying the same thing back to her. And then she started laughing. So she's laughing. So her mood has changed. And then she started crying. And there's something, you know, in that anger behind people, which is sadness underneath it. And somehow or other, by meeting her at the level that she was giving out, it let those tears come out. You know, I am so sorry there's not more psychology involved in what's happening with people with dementia. I don't know that I've probably answered what you said, because, you know, I had to cope with my husband at home, you know, and there was, you know, what did I don't know that I could give you. Probably people who work with people with dementia all the time could give you much better tips than I could. I had both my parents with dementia, but I wasn't a carer. You know, I wasn't the one that was there all the time. So I don't know that it's just a little thing I tried the other day, and as I'm doing it, I'm thinking, oh my God, they're going to come and tell me to walk out of here, because it was kind of a bit out there. But could I say it worked? Well, you know, I guess as a psychologist, I would rather that sadness comes out. You know, if it's coming out as anger, and then I meet the anger with, you know, and she knows I'm not angry. She knows I'm just echoing exactly what she was saying. But it meant that the anger that was there could come out as her sadness. And so then, you know, I could give her a hug. So, but that doesn't mean that sadness can be fixed. You know, it can't.
And I guess in an aged care facility setting, it might be easier for the staff to manage the tears and the anger. I don't know, there could be other repercussions from being an angry resident, as opposed to being a sad, teary resident.
Yeah.
And if there's any time to comfort her, that's surely got to be a better outcome.
The lady who has now been moved on to another facility, every time, and she did it to me, and she would go and stand, and she would just want you to hug her. And I tried to give her prolonged hugs, not just a little hug and pat on the head and, you know, I'm off to see my husband now. But, you know, she needed it from everybody. And then that really sadness, the day after, so I decided to count incidents in her behaviour, and the next day is when I went to the people who are running this nursing home, and in 2 hours she had 29 absolutely furious meltdowns where she spat and kicked and pinched and hit and just was doing all these things. And in the end I would move my husband away because he wouldn't eat with that happening. And then I was sort of around the corner with him, and then I hear she'd gone to the trolley where all the dirty plates were, and she'd picked up all the plates and crashed them on the ground. Like, she was really saying, look at me, this is what I need. And her husband and teenage sons, I only ever saw them once. And I do feel sorry for them, that I don't know, you can't have carers hugging people all day. They're going to, they're about, and they break boundaries, those carers. We've got beautiful carers in this nursing home, and they break boundaries all the time. They'll put their arms around people, and apparently they're not supposed to call them darling or sweetie or anything. They're supposed to call them by their name, but they do. So
and all those things that the Aged Care Commission unearthed about, staff training and all that sort of, and numbers and ratios, and, in a perfect world, as we know, people with dementia really benefit from having much more one-to-one care, and how different that woman you're describing, her world would be.
Yes.
If she was given that care rather than a tablet.
Yeah.
Which is probably what will end up happening to her, sadly.
Well, her geriatrician was the same person as my husband's, and I probably learned things that I shouldn't because I'm there all the time, but she was on the highest dose of whatever she could be on, and she was still so sad and angry with all of those things happening.
Sometimes a really long suffering pet is good.
Yeah. Yes. Well, I haven't thought about asking them about getting a pet. I know when this lady was there, well, they had a bird in the room, which I actually found irritating, the noise of the bird. That wasn't, but this lady had got this whole stand the bird was in and crashed it to the ground, and the bird was flying around. So they couldn't even put Christmas decorations up because she'd be kicking things and trying to break things. And so I suppose this is just sort of really at the top of my mind today, just recently, because I felt for her so much, and I feel awful that she's been moved on, because it won't be better at all in a new place. It can only be worse, really, I imagine. So
I do recall one place I managed many years ago introduced a pet therapy program. It was very, very useful, particularly at Sundowners. And when the ragdoll cat or the rabbit or whatever wasn't available, the ragdoll cat used to sit around people's necks. A lady with whom we thought the pets would not be long-suffering enough, we gave one of those very old-fashioned fur fox stoles. You know those old stoles?
Where
the little animals' paws on it and hit?
Yeah.
And she took to that and wore it as though it was a live animal and responded to it as though it was a live animal. And, of course, it didn't matter if it fell and hit the floor, but nonetheless, it was a comfort to her.
Yeah. I actually find I love fluffy things. I love a fluffy cushion, or, I love rubbing my hands on something fluffy,
Yes,
but
no, I agree.
I
agree, Carol. That tactile sensation is similar to a bucket of mud, and older people do like it. And have you ever seen the reaction people have to? Is it Paro, that white seal pup that they have in a lot of nursing homes. I know Regis facilities use them. A very, very expensive Japanese thing that comes to life and blinks its eyes and talks to you. And of course, if you drop it on the floor, it doesn't suffer like a cat or a dog might, but very, very expensive.
Like
so
how expensive?
And
very
dogs
expensive.
and cats. Yeah, I think they're about $1,000, aren't they, Pamela? Yeah,
right.
You can hire them. Aged care facilities can hire them and trial them with their residents and see.
Right.
And there's also doll therapy. I had a client recently who's just been given a doll and it has to look after it.
Well, this lady who, the bugger lady, she's got 3 teddy bears, one huge one smaller one, and another smaller one. And I was talking to the lifestyle lady at the home about, doll therapy for her, because that's been around for a long time. And she said that she would, at mealtime, she would try and feed the doll and would not take food herself. So now they're into teddy bears, which has got that lovely tactile feel to it. But the dolls, she loved the dolls, but she wouldn't eat. So yeah. But there's something else I'd quite like to say to you, and I actually told Elizabeth about this, and I am embarrassed and ashamed about it. Is this still being recorded, Elizabeth?
We can turn it off now if you like.
Okay, turned off. Yeah.